This question is about gravitational potential energy and gravitational fields. So we're given some information about a spacecraft, and we're told where it is, and we're told that the orbit changes. And we're asked, what is the total change in gravitational potential energy of the spacecraft? So gravitational potential energy is given to us in the formula book. So we've got work done. In this case, it'll be a work done. So we're going to find what the work done is. So the work done will give us an energy. And it's the mass multiplied by the change in potential. So we're going to use the gravitational potential at those two different radii, find the change in gravitational potential, and then we just need to multiply them by the mass to get the energy. Okay, so the gravitational potential to begin with, V equals negative Gm over R. So at the first position, we have negative 6.67 times 10 to the negative 11 multiplied by the mass and that's the mass of the sun. So we need to be careful of that we're not using the mass of the spacecraft because it's moving in the sun's gravitational potential, and we're given the mass of the sun 1.99 times 10 to the 30. So 1.99 times 10 to the 30. And then we've got the distance at that first point. So 1.1 times 10 to the 11. So that's our initial potential. And we can work that out. And we get 2.67 times 10 to the negative 11 multiplied by 1.99 times 10 to the 30, all divided by 1.1 times 10 to the 11. And I can use the E and G button again, and I get negative 1.2, it's 0.666, so 206 times 10 to the 9, and it's in joules per kilogram. So that's the potential at the starting point. At the final point, it's the same equation, it's just R is different. So we get negative, let's move this down, we get negative 6.67 times 10 to the negative 11, multiplied by 1.99 times 10 to the 30, all over, this time it's 2.5 times 10 to the 11. So we can calculate that. And we get 6.67 times 10 to the negative 11 times 1.99 times 10 to the 30, all divided by 2.5 times 10 to the 11. So we get a value of it's 531 times 10 to the 6, so it's 5.3 negative 5.3 times 10 to the 8 joules per kilogram. So that's less negative. So if I subtract one from the other, so I end up at position 2. So I need to take away the value at position 1 when it's deeper in the well. It's more negative, so it's deeper in the well. So as I subtract those two from each other, then I will get a positive value. So 1.206 times 10 to the 9. And I end up with 6.75 times 10 to the 8 joules per kilogram. And that's positive. So then the work done is the mass multiplied by the change in V. So then I just multiply that by the mass. And the mass is given as 1 times 10 to the 6. And I get 6.76 times 10 to the 14 joules, and it's positive.